Question 13. A box on a frictional surface with a linearly increasing force over time beta t at a slightly tilted angle of 85 degrees. Question is, does it lift off first or slide off first? Looking at the solution, we don't need to do any math. And just logically, because it won't lift off until the net vertical force is 0. But prior to that, the horizontal maximum friction is already 0. That sounds right intuitively, but during the exam, you may not feel comfortable just going on that hunch. You may have to just solve it and look at the equation and use that to convince yourself. So you may do something like this. The vertical force is mg minus this linearly increasing force over time plus cosine of this slight angle of a vertical. And because of this, the maximum horizontal force is just this result multiplied by mu. And the horizontal pull is, of course, beta t sine 85 degree. And this won't become clear until you look at the diagram. If you plot the two forces over time, the horizontal force F growing linearly versus time, and the maximum horizontal force coming from this second equation here, it starts at a constant mg mu and decreases over time. Without the mu, you would say this drop in the green line should be much faster than the red line, given the relationship between cosine 85 degrees, which is almost 1, and sine 85 degrees, which is almost 0. But given there's a mu, which is typically a very small number, we don't know which slope is larger. So I just plot them to be similar. But looking at the diagram, this point here, where the green line intersects with the horizontal axis, is where it starts to lift off. That's where the net force becomes 0. And the crossing between red and green is, of course, where the horizontal force exceeds the threshold and this thing starts to slide off. So just looking at the geometry, you can say this time is always smaller than that time. And this hunch is correct.